Let's look at the assignment problem. Assignment problems mean that here we have different carpet salespeople and different jobs. So only one person can go to each job. So red might end up doing job 3 and white might end up doing job 5, but everything has to equal 1. That's the way that we distinguish from other types that we've done. So we have a couple of ways of doing these. One is that we're going to do it on the computer, but the Hungarian method I'm going to do first. So it's done as a reduced matrix. So let me draw it to begin with. So we will set up the matrix. I suppose I could have subtracted already, but so our first one is that we're reducing by row, so we'll end up subtracting the smallest number for each row. So I know this isn't very neat, but I can still fit it in the same page, so I'm going to do that. So this is by row, step 1. So I'm subtracting the smallest number from each row, which is 30. So I'm going to have 0, 14, 8, 17, 1. And the next one, the smallest is 25. So 0, 7, 20, 19, and 0. And the next one is 23. So 0, 17, 14, 16, and 6. And the next one we're taking off is 26 again. So 26, 12, 11, 19, and 2. And the last one, 26, yet again. So 0, 8, 18, 17, and 2. So our second one, our second step, is to reduce by column. And I will now get all zeros here. And I'm subtracting 7 now. And then 8. And 16. And 0. So the deal here now is that we need to cross out with the minimum number of lines the zeros. So let me change my pen color here. And, well, this is an obvious one. And remember, I'm taking the least number. So I can do this, this, and this. It's up to you how you decide. This makes a difference on our next move, but you'll see. So let's look at the values that we have now. And I'm now looking for, oops, I have one more line that will still work, right? I can still, there's still, I should not have used this one. So let me see if I can undo that one. There we go, because look, there's 2 zeros in here, so I should have used this one. So I have 1, 2, 3, 4 lines. I need to have 5 lines, because that's the number of unknowns before I know I'm finished. So I look for the smallest uncovered, which in our case is 1. So in this case, it's a 1. So I'm going to subtract it from all the uncovered, and I'm going to add to the intersections. So my new matrix now is going to look like a 1, because that's intersection, a 1, and 2 zeros. And the next ones I'm just copying like they are, subtracting 1 from here. Trying to be able to see everything. So 0, 12, 6, 2, 9, and 1, 3, 0, 2, 0, and 1, 0, 6, 1, 1. And now I'm going to do it again. See if there are enough zeros that I can cross them out. So here's 1. Let's see, there's 1 that'll take 2. And then I have this one, and this one. I have no choice. So I'm done. I have 5 lines there. So let's mark them. So these are in the solution now. So and I think that the way this worked is that I had colors down the side, so red, white, blue, green, and brown, and I had jobs at the top. So we're looking at where there is only one choice. Well, so for the first one, red must take number 3. It's the only one in the red column, so it has to be. And I also know that blue must take number 1, because that's all that it has in its column as well. So once those are gone, so this one, and this one is gone, I now look, wait, that should have been green. And I look at blue, it has to be 4. And that means the 4s are gone, leaving brown having to do 2. And so the 2s are off, leaving white to do 5. And the total cost here, so red is 3, that's 38. Green is 1, that's 26. Blue is 4, that's 39. Brown is 2, that's 34. And white is 5, that's 25. 9, 18, 26, 32, 5, 11, 16. So this will be the minimum cost that you will get on Excel. And in this case, it looks like there is only one solution, but you may get the same 162, but maybe not the exact same combination of values. But in this case, there is only one solution.